Today's video will explain the similarities and differences between a unit test and an integration test. Hello, I'm James Selfridge. Integration tests are similar to unit tests in that they're in-code checks to verify the program works as expected. But they're different in one important way. They're going to test how individual units interoperate with each other. This video will compare and contrast unit tests and integration tests so you can better understand how to build integration tests to give you more assurance that your program works as expected. Okay, first of all, we have to have some definitions here. Now remember, a unit test is a test designed to exercise one specific function or method independent of the rest of the program. And once you have a collection of unit tests finished, then you can do an integration test. An integration test will verify the collection of units. Once all the different integration tests are finished, then we can perform some black box testing on the system using system testing. This does the publicly accessible interfaces, such as mouse clicks, keyboard events, network interfaces, and we test this with automation softwares like Selenium. And then once the system tests are finished, then we can see if we're fit for use with acceptance testing. Now, what we're going to try to do here is really understand the difference between a unit test and an integration test. A unit test is a white box. In other words, we have access to the member variables as well as to the internals of the class. Developer written, not developed by a tester or quality assurance engineer. The test gets written automatically and not manually with mouse clicks. Used to validate a single function or method in isolation of the rest of the program. And this contrasts with an integration test, which is a white box, the same, developer written, the same, automation, the same, used to validate assembled units operating as they would in a finished system. Now let's take a look at these two very closely here. The unit tests and the integration tests both exist in the code base. We compile it into the code base. Both of them use asserts to indicate errors. And both of them are written, maintained, and run by developers. But that's where the similarities end. A unit test exercises one single function or method, whereas an integration test exercises many functions, methods, or even classes. A unit test failure points to specific code errors, whereas integration test errors are often difficult to debug because it could be any one of a dozen or maybe even 100 different functions. Test cases are often contrived. I mean, they're contrived because we try to put the program in a very specific case so we can better isolate that function or test, whereas integration tests are true to how the code is being used. They're authentic. In order to understand this, we'll take a look at the chess move called en passant. En passant is a chess move performed by a pawn capturing another pawn. This move is distinct from normal pawn moves in that the enemy pawn is on the same rank as the attacking pawn. For a pawn to perform an en passant capture, the following must occur. Number one, the enemy pawn advances 2 squares on the previous turn. Second, the attacking pawn must be adjacent to the newly moved pawn. And number 3, the attacking pawn moves into the square the enemy pawn just passed over. Let's take a look at that. Okay, here we have the chess game, and I'm going to move my pawn forward, and then I'm going to move my pawn forward. Now I'm going to move my pawn forward, and now I'm going to move my pawn forward. Now at this point in time, this pawn right here has just moved, this one has not. And when I try to perform an en passant, I can do it on the one that just moved. And this allows me to capture even though there's not a piece in that location. Now let's take a look at the unit test for this class. So this is the pawn that I'm moving because I have in parentheses, and I want to be able to perform en passant to this location and this location. I'm not going to want to move forward. So I should have 2 possible moves here. Now what I'm going to do is I'm going to start with an empty board. Now this empty board is a double, which means that it's not a real board. In fact, it's filled with null pointers. The board is completely empty. It doesn't do anything. It only has pieces in 3 locations. And those 3 locations are 0, 4, 2, 4, and 1, 5. In other words, the only 2 pieces that I have. I'm going to have one method under test to get move, and I'm going to be able to have 2 en passant moves, both to A6 as well as to C6, both to A6 as well as to C6. Now notice that it's actually impossible to do this in the real world because I cannot have 2 different pieces, this black pawn, that just barely moved. In other words, only one could have previously moved. So this particular board setup is impossible, but we're okay with that with a unit test because we're trying to exercise a very specific part of the program. Also, this is not using the real board. It's not using the real setup. And I'm going to create fake pieces in order to perform the en passant. just so that I can isolate this particular function under test. And that specific function or test is getMove. Now we will contrast that with a integration test. This integration test is also going to exercise en passant. And the way I'm going to do that is I'm going to start with a board that is set up in the standard way with all the pieces as you'd expect them. Then I'm going to move the pieces exactly as if the player had moved them. I'm moving from F2 to F4, B7 to B5, F4 to F5, and so on. Each one of these move is going to execute several different functions, and there's perhaps maybe 100 different functions being executed here. When I'm finished, then I will have my en passant performed. Then I'm going to verify by once again checking the board, the authentic board, that all the pieces are exactly where I expect them to be. And each one of these particular cases here is also going to be several lines of code because I'm going to create a position, I'm going to look up the board, I'm going to compare that against the rook. The unit test is a critical part of this process because I can isolate the specific method under test, and therefore if a bug happened, I only know to look in one place to find that bug. The integration test, on the other hand, gives me greater assurance that the overall program works together, that the interrelation between the pieces, as well as with the move class, as well as with the board class, all work the way we expect. I can have greater confidence that the program works as I want it to. Let's take a look at another example. Imagine a rocket, a lunar lander from Apollo 11, is attempting to land on the moon. The rocket moves according to Newtonian physics. It honors inertia, falls to the moon according to the force of gravity, and responds to thrust emitting from the rocket engine. We would like to verify this with both a unit test as well as with an integration test. So first we'll start with our unit test. This is going to be the law of inertia. And to do inertia, we're going to have the distance formula. So we're going to have our position, which is going to update according to acceleration, velocity, and time. But remember, I would like to isolate the specific add method in isolation of the rest of the program. In other words, I don't want bugs or incomplete code in acceleration or velocity to impact this unit test. So how am I going to accomplish this? Well, I have a special version of velocity and a special version of acceleration. Let's take a look at those. My special version of acceleration always returns 0.2 and 0.3 for ddx and ddy, and my special version of velocity always returns 0.5 and 0.4 according to dx and dy. And it's all based on a velocity dummy, which asserts false if anything else is being called. This allows me to completely isolate this method from any other part of the program because only this method is being called. Therefore, if either of these asserts fire, then I know it's because of this method and it's not because of anything in velocity or acceleration. Let's contrast that with an integration test. In the integration test, I'm going to start with a lander. I'm going to set its position using public interfaces. I'm going to set the velocity according to public interfaces. I'm going to set the acceleration according to public interfaces, as well as my thrust. I'm going to set the angle according to public interfaces. The setup alone is probably going to call 24 functions. Then I'm going to coast for 1 second, 1 second, 1 second, 1 second, 10 individual times. And when I'm finished, the lander better be in a position of velocity that I expect. And how do I know that? Well, because I perform the calculations by hand, and then I want to verify that what I did by hand matches the actual position and velocity of the lander. If either of these asserts fail to fire, then it's going to be very difficult to find out exactly where this happened because this lander.coast is going to call many different functions in order to compute it. However, it will give me assurance that the lander works as expected. Whereas if this asserts fail, then I know exactly where the problem is. Both are required to adequately test this program. We can learn more about integration testing in the integration test chapter of the software design textbook.